it can be very useful to calculate the equilibrium concentrations of reactants and products. Equilibrium constants, probably most of the known reactions, someone has studied and measured the equilibrium constant at various temperatures. So we can go look up the equilibrium constant for a given reaction. We would like to know, what is the equilibrium concentration for my particular situation here? And there's two ways to calculate, two types of problems. The first is where we know the equilibrium constant, and we know all but one of the equilibrium concentrations. Well, we know everything except one. We plug the numbers in, we have one variable, we solve for it. The second type of problem is much more common, where we know the equilibrium constant and we know what the initial concentrations were, because we put stuff in the flask or the container, right? We know what the concentration was to start with. We looked up the equilibrium constant. It churns away, gets to equilibrium. Now what are the concentrations? In this situation, you have to measure at least one, maybe more things. You have to measure their concentrations at equilibrium, which is a lot easier said than done. So this step, which is more common, is going to require an ice table. So let's do an example of the first one. Diatomic iodine decomposes to form iodine atoms. We've got a reaction, we've got a K. In an equilibrium mixture, the concentration of I2 is 0.1 molar. It's really not that hard to say. So I'm going to write the expression for the equilibrium constant. So it's the concentration of iodine atoms squared divided by the concentration of iodine molecules. We know what K is, 0.011. We know what the concentration of I2 is at equilibrium because they told us, 0.10. We're trying to find the concentration of iodine atoms. So this is the easier one. We almost never have to do this. We usually have to do the harder one.
Can you say harder one, an easier one? The harder way being making an ice?
Yeah. The harder one is making the ice table. There's just more steps. But that's much more practical because usually you don't know the equilibrium concentrations. That's why you're wanting to know the equilibrium concentrations. Yeah. So here's a conceptual question. For the reaction A goes to 2B, Kc equals 4. Reaction mixture at equilibrium contains concentration of A that's equal to 1 molar. What's the concentration of B in the reaction mixture? There is math involved here, but there's not math that we really need a calculator for. QC would be the concentration of B squared over A, right? Products over reactants. We know that Kc is equal to 4 because they told us. And we know that A is 1 molar because they told us. So B squared must be 4. B squared is 4. And B must be 2. Everybody okay with that? Okay, what if we know the initial concentrations or pressures? We know the equilibrium constant. This is more common. And we've got a specific procedure here. So there's some steps involved. We're going to start by making an ice table. Then we're going to represent the changes in concentration in terms of x. And that's where we use the coefficients from the equation. Then we're going to add the initial row to the change row to find out the equilibrium concentration in terms of x. And then we'll plug those concentrations into the equilibrium constant expression and solve for x. So we're going to do a couple of examples here. The first one is with little numbers. So here we have A goes to 2B, and we've got our equilibrium constant and an initial concentration of A. It's the only reactant. So we'll make our ice table. Remember, ice is initial change equilibrium. Initially, we had 1 mole per liter of A. How many moles per liter of B? 0. It doesn't say that in the problem. They don't tell us what the product's concentration is. We're supposed to assume that it's 0. Usually when you do a reaction, do you put all the reactants and all the products in? No, you put the reactants in because the point of doing it is to get the reactants, right? So very commonly we start with reactants and no products. So that's a 0. You cannot go lower than 0. You can't have negative concentration, right? So this is going to change by positive x. And because there's a 2 in the balanced chemical equation, it's going to change by plus 2x. This is where the arrow is, separating reactants and products. If the product is increasing, the reactant is decreasing. This is going to go down by x, and it's just 1x because there's an unwritten 1 here. When one of these reacts, it makes 2 of those. So it's all about the stoichiometry. It's great if you can really see and understand how that works, but it's also pretty easy if you just are like, well, I'm supposed to use the coefficient in front of the x. That works every time. So we add these, 1 and negative x, we get 1 minus x. Over here, 0 plus 2x, we get 2x. So we're going to write the expression for k. It's going to be b squared over a. And then we're going to put things into it. So we know what k is, 0.33. This is the concentration of B, 2x squared. And then we're dividing by the concentration of A. So there's A, we're dividing by that. Okay? We're using x because we don't know what the change is. It's going to be x. We add these together. This is going to represent the concentration at equilibrium for A, concentration at equilibrium for B. So we can plug those representations into our equilibrium expression. We know what the constant is. Now we have an equation with one variable. We can solve for x. So, in math class, what you'd probably do is, you just like, oh, they make us show all our work all the time. So 2x, the quantity squared would be 4x squared, right? And then we would distribute this. And then put everything on one side. How do you solve that? Quadratic equation. The solver on your calculator. You don't even have to use the polynomial solver, you can just use the number solver. Yeah. So, we could use the quadratic equation. We're not going to do that because it's dumb. It's tedious, and you make mistakes, and we don't have to do that kind of stuff anymore. So I'm going to use the number solver. We do not need to rearrange this at all. We can just take what we wrote up here and type this into our number solver. Isn't that beautiful? So if you want to borrow one of these calculators to do it, I encourage you to do so. I have more down below if we run out. So I'm just going to get into the number solver. If you have like a TI-84 or something like that, you can also solve this, but you're going to have to set this equal to 0. So I would probably do 2x squared over 1 minus x minus 0.33 is equal to 0. Because it's just going to want you to put in an expression that's equal to 0. But I don't have one of those calculators for multiple reasons. So I'm going to type this in, and you want to be careful to type it in just as it looks. It's important to put parentheses around the 2x because the 2 is also squared. Okay. So I put that in there, I press enter. I'm going to start it off at 0. Just going to get rid of this. This tells me x equals 0.2489. Why was 6 afraid of 7? Because 7, 8, 9. What do you call a magician that's lost his magic? Ian.
That's awesome.
There's these guys that do these reels called deer blind dad jokes, and they're in their camo and stuff, and they're sitting behind a deer blind. And the funniest thing about it really is watching 3 middle-aged men giggle, right? They are just cracking each other up, but some of their jokes are actually funny. That's where I got that one. Okay, we found x. Is this our answer? No. We want the concentrations, right? Well, the concentration of A at equilibrium is 1 minus x. So the concentration of A is 1 minus x. Yep, I did that wrong. And I was going to do some, fancy rounding in my head there. It's approximately 0.75. Don't tell the 1A instructors I did that. It's not correct sig figs either, but we don't care. B is 2 times x, or 0.50. Any questions? Have I done a thumb poll with you before? Okay, so everybody's going to show me their thumb. Thumbs up if you're like, got it. Thumb to the side, kind of confused. Thumb down, yeah, totally lost me. Okay, so just show me your thumbs. Yeah, northeast is not an option, but okay.
3/4.
I think that's good. So we're going to do a couple more examples, so hopefully that'll clear it up. More real examples, right? So here, nitrogen and oxygen react to form 2 NO, and the equilibrium constant is 0.055. The reaction starts with only the product and no reactants. Kind of weird, but whatever. Find the equilibrium concentrations of all three of the things. We have initial concentrations in K. We need an ice table. The header for the ice table is going to be the balanced chemical equation. So N2 and O2, equilibrium arrow to no. We're going to have a row for the initial concentrations, a row for the change, and a row for the equilibrium. The ice table. I like to put a double line here where the arrow is. And just now I realized, it'd be best if I didn't run those lines all the way through the equation. So I stopped this time. So that's new. Figured that out finally. Just so we're very aware of, these are reactants, these are products. So, ice table. Put in the initial concentrations. Starts with only the product. So the product concentration, we're told, is 0.01. Just whatever they say, you write it in. What are the concentrations for N2 and O2? 0. There isn't any. This time they came out and told us. Okay, then we're going to do the change row in terms of X. So can we go down from 0? No. So this must be plus. Plus X. There's no coefficient here or here, so I'm not going to write the coefficient here. The other reactant will also be plus, and again, it's just 1. Everything on one side of the arrows, the equilibrium thing, has to have the same sign. So the other side then is going to be going down. And this one has a 2 in front of it. So this is going to go down by 2x. Then we're going to add the rows. 0 plus x is x. Again, 0 plus x is x. And this is 0.0100 minus 2x. We're going to be doing this a lot. This is important. What do we do now? Equilibrium constant. We know what the equilibrium constant is, and we can write an expression in terms of concentrations. So you always want to actually write out the equilibrium constant expression. And so the numerator is no squared. That's when your mom is really upset. She's not only yelling, but it's squared.
Don't be cute.
And then down here, you got N2 and O2. I'm going to take these equilibrium expressions and plug them in here. And I'm going to take the equilibrium constant that I was given and put that in for Kc. So on top, I have this mess, squared. This guy is up here. And that's divided by n. Concentration of n is equal to x times the concentration of O2, which is also equal to x. Is it okay that those are equal? Can they have the same value? Yeah, they can. Because when this reacts to form these, we're starting with none of it, it's going to form equal amounts of N2 and O2. Their concentrations are going to be the same. So we need to solve this equation for x. And you could leave this as x times x in the denominator, or you could say, well, that's x squared. Whatever you want to do. .055. Calculator is saying it's 0.004475. Too many sig figs. It's okay. Anybody else get that? Well, I'll assume I'm right then. The concentration of N2 is equal to the concentration of O2. They're both equal to x. Is going to equal 0.0100 minus 0.00475 times 2. Forgot the 2. If you use the solver, your calculator has this value stored in the x register. And so I can go 0.01 minus 2 times, and I can press that same x button I used for the variable, and it'll do it for me. I don't have to type it in again. When we look at the answers, it gives this as 0.011. So it rounded that. That's okay. Any questions? Okay, let's do another thumb poll. Show me your thumbs. So I've got thumbs up and people not showing me their thumbs. Well, I got thumbs like
3/4.
3/4. Yeah. So someone who's not 100% asked me a question. You're not the only one who's kind of at half-mast. Yes?
If I get a different number for x on the calculator, even though I use the number solver, is it just an input thing?
It depends. What number did you get?
It was actually me. I got .00566.
Okay. So this is like an x squared minus x plus something equation, right? These can often have two roots, two solutions. So there's two possibilities here. You found the other root, or you made a mistake in the typing in the equation. So I'm going to go look at mine. And what I'm going to do to try to get a different answer is I'm going to start with a different x and see if it gives me a different answer. Okay,
How would we determine which is which if we're getting multiple?
that's an excellent question. So what was the x that you got?
Um, 0.005664.
Like that? Okay, so let's say the calculator gives you that. Let's plug that in and see if it works. So it's a positive number. That would be a reasonable concentration for X. Let's plug it in here. 0.010 minus 2 times 0.00564. And I get a negative concentration. Is that possible? No, not possible. Most of the time, the calculator's going to spit out the correct root. If you've got something where like it's x or 2x or something and it's giving you a negative root, obviously that's not going to work. This one looked like it was fine until we plugged it into here, and that gave me a concentration for no of negative 0.00128. Not possible. If your calculator gives you a root that's not working, then you start with a different value of x. Now with this one, I started with 1 and it choked on me. I was trying to get the other root. So sometimes you just kind of have to play around with it a little bit.
Did you say you started with 1, this is K? You talked about when it prompts enter and solve.
Yeah.
X equals, what if I just put 0 for every single time I have to,
That's what I do.
that's fine.
Yeah, I put 0 every time. So at least I remember what I started with. Because otherwise I'm starting with the answer from the last problem. And then if it doesn't work out, I'm like, well, do I need to go bigger or smaller? I don't know. I don't know what it was because I don't remember.
That's how it happened with me, is it was still saved as the previous.
Right.
0.02.
Yep.
whatever.
So when I put in 0.01, I get this value. Okay? I know it's wrong when I finish the problem and I get a negative concentration. So starting with 0 seems to work most of the time. Okay, thumbs. Okay, I'm only seeing up. Okay, good. Okay, you're going to do this one on your own. Because I'm not going to take your exam for you.
It's so real.
Yeah, so work on this. I'm going to walk around and answer questions. I'm also going to kind of scribble some steps up here.
And it only happens sometimes. What was it? Like, it's not an every time. It happens under certain conditions. Now I don't know what they are. But I know that Advil fixes it. Which is really weird. Yeah.
So I'm just going to go through this real quick. N204.
You did. Yes.
We're just ignoring the temperature, right?
Yes.
Okay.
cry a little because I'm bro, like, give me what I need and leave me alone.
The thing is, you know, if you were actually doing research, you don't just have one thing that you don't need. You've got like the universe.
Ugh, that's gross.
Yeah. So be thankful that there's only one or two units that are gonna.
Be thankful now before you get killed later. Killed.
The two things are equal to each other.
It's part of becoming a chemist.
I guess, like being reborn or something. That'd be so awesome. Rip it off.
You want to
We would be a good
That's like a big no. So tight.
I'm joking about it.
Oh, I just don't worry. It would be okay if you were a friend.
Okay, so when I started with x equals 0, I got -3. It's like, okay, that's not good. When I started with x, I put this into my solver and I started with x equals 0, and that's what it gave me.
I didn't get that when I used X equals.
There's been, I think there's been a disturbance in the vortex because there's been some really, I need to come over here maybe.
Come over in the magnetic field.
Well, how did you put it?
Okay. I put in 3.3 instead of 0.36.
There we go. Bingo.
User error.
So, yeah.
That hits the spot. Still working.
So,
That's not right. I have 0.02.
okay, so after realizing that I made numerous errors typing the equation into the calculator, I think I finally came up with the right number.
Okay.
Yeah.
We're here to help each other.
We are here to help each other. So, what am I looking at here? N204 is 0.0250 minus.
Oh my god, I love pictures. Definitely the whole thing. Damn. There goes my point.
They're probably
These things so absent-minded.
no, it's
What's going on? What are you talking about?
Eventually, 3 to 5 business days maybe.
Okay. So, the book is telling me that this answer is 0.041, good enough. And this one is 0.005, good enough. Okay, any questions about this process? See, yesterday, yeah, question.
On test day, when we have to perform, is it gonna be okay to use number solver?
You can use a number solver on an exam. Yes. And, in fact, if you're having trouble with your number solver on an exam, I will entertain questions. I may not answer them, but if it's, maybe I don't know the answer. If it's, if you've got everything typed in right and it's just a calculator thing, I'll help you fix that, okay? But yeah, we're just not going to do the quadratic equation under any circumstances.
Yay.
If you really want to, just don't tell me about it. I don't want to hear about it. So yesterday, what happened is I did this problem as an example, and I made students do the next problem. So that was obviously my mistake today. I asked you to do the wrong problem on your own. So this one actually worked really good. So this one is a teeny bit different, right? This is, that's not the right slide. This is,
What's different about it?
see, it's your fault for not shooting me when I asked you to. This should not continue. Partial pressures. Everything is the same. So let's just run through this real quick. So we've got I2 and Cl2 making, what is that, Ickle? Initial change equilibrium. We have initial pressures as both reactants with partial pressure of 0.15 and no product, 0. So sometimes the reactant concentrations go down and the products go up. Sometimes the reactant concentrations go up and the products go down. If you have a 0 as an initial concentration, that one has to go up. If you've got numbers for everything, it might not be obvious which way it's going to go. The great news is if you put the wrong sign on there, when you find the answer, it's going to have a negative sign on it, and when you plug it in, it'll all work out and you'll get the same answers. So this has to be plus x, and it needs to be 2. And this will be minus x, and this will be minus x. K is Ickle squared divided by I times Cl. So this is the Kp. If they gave us the Kc, we would have to convert it to Kp. We can do that. Thankfully, they didn't make us do that here. So ICl Ickle is that guy, 2x squared. And then I2 is 0.150 minus x. And Cl2 is also 0.150 minus x. You can write them out, or you can just put them in there squared. So I wrote concentration out of habit. This is the partial pressure of ICL. It's the partial pressure of I2, which is equal to partial pressure of Cl2. Any questions?